Welcome back. This video is to help you through homework 3-2. So in your notes, hopefully you wrote down all the different types of end behavior that you can have for a graph. That does make this quite a bit easier to solve. All right, so I just want to point out that this is negative and it is an even degree because of the squared right here. Okay, so since it's negative even, the end behavior will, on the left, it's going to fall, and on the right, it will fall as well. And so if you take a look at these graphs, there's only one where that happens. And also because it's a quadratic, the most times it can cross is 2 places, so this one is out. And so that's why it ends up being that one. All right, let's try the next one. So for this next one, let me zoom in here. So we have, we're basically just describing the end behavior, right? So it says 14x cubed plus 7x. Now notice that the highest degree is the one we really look at, right? So this is positive because there's not a negative in front. It's also odd because of the fact it's being raised to the 3rd power, okay? So all positive odd graphs on the left, they will fall, and on the right, they will rise. Okay, that is just by definition, we're going to have an end behavior that looks like that. So that's how we get the graph rises to the right and the graph falls to the left. All right, let's try number 3. So for number 3, we have, we're doing the same thing. I'm going to be taking really a look at 5x squared. The 5 is positive. And because it's a squared, it's considered even, right? So this exponent makes it even. And so if it's positive even, on the left, it will rise, and on the right, it will also rise. And so I'm looking for the graph rising on the right and also rising on the left. So all positive even graphs will have those characteristics. All right, so for number 4, same idea. Remember, you're always looking at the highest exponent. So in this case, it's negative 2x squared. This time it is negative, and it's even because it's squared. All negative even graphs have a certain end behavior. On the left, the graph will fall, and on the right, the graph will fall. And so it'll look like basically like that. And so that's why we have it falling to the left and to the right. And so if you look in your notes, you'll notice that that's what happens to all negative even graphs. Okay, let's take a look at number 5. So number 5 is the same idea. I'm going to take a look at the negative x to the 6th power. It is negative. It is even. Negative even graphs, the same thing happens every time. Ooh, sorry. On the left, they will fall, and on the right, they will fall. All right, so that is just what is going on with that graph. Okay, let's move on to number 6. So for number 6, we have quite a bit more going on. So it says, consider the following, find the zeros, and then you're also going to eventually graph it, all right? So we have x squared minus 81, and we can actually find the zeros by setting it equal to 0. And we could just add 81 to both sides, or we could do difference of squares factoring. That would kind of be like your choice. And then I'm going to take the square root of both sides. I don't forget the positive or negative. And so I end up with positive 9 and negative 9. So you can see here, they want us to list that with just commas in between. And then for my smaller x value, the multiplicity would just be 1 because I only got negative 1 time. And so we would say odd multiplicity. And then the same would be true for the larger since we only got it 1 time. And then determining the maximum number of turning points of the function. Well, if we have 2 zeros, we're only going to have 1 turning point. So if we had 3 zeros, we could have, the maximum would be 2. If we had 4 zeros, it would be 3, and so on. So that's how we get 1 here for our turning point. All right, and so it's going to cross at negative 9 and positive 9. So when we find the zeros, graphically, we're looking for where it crosses at. So like it could possibly be this answer choice, but because it's a positive, so because at the very beginning it's positive and it's even, the in behavior is going to be to rise on the left and to rise on the right. Okay, so this one's going to be out. It's going to look similar though, but it's going to be flipped over. Yeah, so this would be the right one. Okay, so I find the zeros. The -9 and the +9 helps me out. And then also the in behavior. So the in behavior, since it was a positive x squared, is on the left, it's going to rise, and on the right, it's going to rise. And so that's why ultimately I would pick that choice, okay? All right, let's move on to the next question. All right, let me zoom in here. Okay, so it says, consider this following, find all the zeros, and we'll have to enter that in. Okay, so I want to start out with, and this is number 7, so I want to start out with the fact that we have this whole thing here, right? So what we'll do is we'll set each part equal to 0, all right? And so what happens here is this really is what we call a double root, because I get like plus or minus 0. So really I get, and plus or minus 0 would just be 0 twice. So we call this a multiplicity of 2, all right? So we're gonna have a 0 at 0. And you can see that the smallest value we would say is even multiplicity because it had this squared on it. All right, now to solve this one, I can do factor by grouping and set it equal to 0, and I would get 3t minus 8 and then t minus 1. All right, so if I worked out the factor by grouping, that's what I would factor it to. And so I would set each piece equal to 0. And I would get positive 1 here. And over here, I would get positive 8 over 3, right? Okay, so 8 over 3 and positive 1. And they only have a multiplicity of 1 because they're not to the squared power when we factor it, right? If this was to the 4th power, then we'd have to take care of that. So that's why we say odd multiplicity for those other values. But I do have 3 zeros at 0, 1, and 8 over 3. All right, and then as far as the turning points go, the 0 actually counts as 2, right? So we had 0 twice, then we had 1, and then we had 8 over 3. So that was 4, and then 4 minus 1 is how we end up with 3. All right, so 3 turning points for that. And then we want to pay attention to our in behavior. So it is a 4th power and it's positive. So it should rise on the left and right. So I'll be looking for a graph that rises on the left and the right, and that you can see because it's got at 0, so it should be crossing at 0, and it's just barely touching because of the multiplicity of 2, and then at 1, and also at 8 over 3. So 0, 1, and 8 over 3, and then I've got this rise and rise on the left and right, and so that's why I would pick that one. Okay. Let's try this next one. It says, consider the following, find all the real zeros, and then, of course, put a comma in between. All right, so this one's gonna take a little bit more work because I actually have to like completely factor it out first, all right? So I'm gonna set it equal to 0. They all have an x in common, so I'm gonna take out an x and a 6 actually. So I would have x squared minus 4x plus 1 equals 0. And then I'm gonna, like, that makes me have a 0 at 0, because if I set 6x equal to 0, I get 0. So x is equal to 0 is one of my solutions. And then this x squared minus 4x plus 1, you would have to do the quadratic formula to get your roots, okay? And you know how to do the quadratic formula because we had that in the past. You would get plus or minus, or you end up with 2 plus or minus the square root of 3. So 2 plus the square root of 3 is one solution, and 2 minus the square root of the 3 is the other. So this 0 counts only as 1, and these count as 1 as well. So that's why these are all considered odd multiplicity, because I didn't take out an x squared here, I only took out an x. All right, and then for in behavior, it is positive and odd. So on the left, it should fall, and on the right, it should rise. Okay, so that's what we're going to be looking for here. The maximum number of turning points is 2 because we have 3 zeros minus 1 is 2. All right, so if you look at your graphs, the only one where this happens is right here. All right, so you can see it is kind of actually difficult to see. To be honest, they should zoom in or something, so I apologize for that. But it is following the end behavior. It's just you're only seeing part of your graph. So I'm not sure if I like that question very much. I promise it won't be on your test. Okay, let's try number 9. All right, so number 9 is very, similar to the one we just did. All right, so let me zoom in a little bit. So I'm going to take this equation and I'm going to set it equal to 0. All right, and so they all have a t in common. So I take out a t, and so it looks like this. Okay, that simply means that this t over here is going to be set equal to 0, and so I will have a 0 as part of my answer. All right, this I would have to factor. And I'm just looking for two numbers that add to get negative 12 that multiply to get positive 36, which would be t squared minus 6 and t squared minus 6. Okay, that's the same thing twice. All right, so when I set this equal to 0 and I set this equal to 0, I'm going to add 6 to both sides and take the square root. And so I get plus or minus the square root of 6 plus or minus the square root of 6. Okay, this is very interesting because this means negative square root of 6 would be considered a even multiplicity because it's basically it'd be a multiplicity of 2. And then positive square root of 6, because we have it twice, would also be considered an even multiplicity of 2. All right, so that's how I end up with even for the smallest value, which is negative square root of 6, odd for 0, and then even for the square root of 6. Okay, so that's kind of crazy. And then what's interesting is that this counts as 2, and this counts as 2, and this counts as 1. So that's 5. So 5 minus 1 is how we end up with 4. And you can also just subtract 1 from that value, right? Once again, we'll graph it. It's positive and odd, so on the left it should fall, and on the right it should rise. And so the one that's doing that would be over here. And I can show you that here and here is the multiplicity of 2. It just barely touches and goes back. And then it's going clearly across 0. And it's following the end behavior. All right, let's move on to the next page. Let me zoom in here. All right, so it says find a polynomial function that has the given zeros. And we have 0, negative 8, and negative 5. Okay, so this is kind of fun. We are going to reverse factor in a way, because for it to be a 0, at one point it was just an x. And for it to have a 0 at negative 8, it used to be x plus 8. And then for it to have a 0 at negative 5, it used to be x plus 5, right? That's how the signs change. So now I can just multiply this out. And I might actually multiply this together because we're used to that, right? And then I'll multiply by the x. So if I make a box or I distribute, I get x squared plus 8x plus 5x plus 40, which is x squared plus 13x plus 40. And then I multiply that by x, and I get x cubed plus 13x squared plus 40x, which is right here. All right, and then number 11 follows. So for number 11, it would be very similar. I would have x, and then I would have x minus 1, x minus 8, right? I just change the signs as I put them in. I would probably multiply that together. I can make a box or use distributive property. I would get x squared minus 1x minus 8x plus 8, which would be x squared minus 9x plus 8. Bring down the x cubed minus 9x squared plus 8x, which is how they get that. So those are not that bad. And then last, we have this crazy one, which says to find the function that has these as zeros, which is very fun. So I still need to change my signs. All right, so there is a little trick that I want to show you. So when I change my signs, I'm going to get negative 1 minus the square root of 6, and I'm going to get negative 1 plus the square root of 6. So right, all I'm doing is changing my signs here and here. Okay, now I'm going to have an x squared, and then when if I try to multiply this out, then basically I'm just adding these together and then I'm multiplying them as well. So when I add these together, what happens is naturally that's going to go away, and I'm just left with -1 plus -1, which is how we get the -2x right there. All right, so then to get the last term, I would multiply the -1. Let me go off to the side here. I'll go down here. So -1 minus the square root of 6 times -1 plus the square root of 6. Okay, when I multiply this together, they're conjugates. So really I just have -1 times -1, which is +1, and then negative square root of 6 times the positive square root of 6, which is just -6. And so I end up with -5. All right, so you can just add those together. You can multiply them together. And what's fascinating is you could actually use your calculator if you wanted to. You would get the same result. All right, I hope this helps you on homework 3-2. Have a good day. Bye.